What happens if you fall into a black hole? Here's the honest answer. It depends on which one. Pick the wrong black hole and you're torn apart before you even arrive. Pick the right one, and you could cross the point of no return without feeling a thing. Let's find out. Black holes have a reputation problem. In the movies, they're cosmic vacuum cleaners, roaring monsters that hunt down anything nearby. The truth is calmer and much stranger. A black hole is simply a place where gravity has won. So much mass is packed into so little space that beyond a certain boundary nothing can leave. Not rockets, not radio signals, not even light. That boundary has a name. The event horizon. It isn't a surface you could touch. It's an invisible line in space, the point of no return, and what happens to you at that line depends entirely on the size of the black hole you've chosen. So let's do this properly. Let's fall in twice first. The small one. The nearest black hole we know of is called Gaia BH1, about 1,500 light-years away, weighing nearly 10 times the mass of our Sun. That sounds enormous, but for a black hole, it's tiny. Its event horizon would span only about 60 kilometers, roughly the width of a large city. So why would the small one be the dangerous one? It comes down to your feet. As you fall feet first, your feet are meaningfully closer to the center than your head. Closer means stronger gravity. So your feet get pulled harder than your head, and the difference grows fast. This is a tidal force, the same effect the moon uses to stretch Earth's oceans into tides. Except here, the stretching never stops. You're pulled longer and squeezed thinner like dough through a pasta machine. Physicists genuinely call it spaghettification. And around a small black hole, it happens early. You would be torn apart thousands of kilometers before the horizon. You never even reach the point of no return. The small black hole shreds you on the doorstep. Now the second fall, and this time, we choose a giant. At the center of our galaxy sits Sagittarius, a star, a supermassive black hole weighing about 4.3 million suns, roughly 26,000 light-years from Earth. Its event horizon is about 25 million kilometers across. And here's the part almost nobody expects. Bigger is gentler. Because the horizon sits so far from the center, the difference in pull between your feet and your head out there is tiny. You could cross the event horizon of a supermassive black hole and feel nothing. No jolt, no warning, no sign at all. The point of no return passes like any other moment of your life. And we actually know what this would look like. A couple of years ago, a NASA astrophysicist named Jeremy Schnittman used a supercomputer to simulate the plunge frame by frame, using the real equations of general relativity. As you fall, the sky behind you squeezes into a shrinking ring of distorted starlight, and the darkness swallows your view. Once you cross the horizon, the simulation gives you 12.8 seconds. That's how long you have to about 128,000 kilometers of falling, before the stretching finally catches up with you near the center, where even a giant becomes deadly. 12.8 seconds. What would you think about? If you like having the universe decoded like this, one big question, every few days, that's the whole channel. Subscribe, because we're just getting to the strange part. Because here's the question nobody asks. What does your best friend see watching your fall from a safe distance? Gravity doesn't just bend space, it bends time. The deeper you sink into a gravitational field, the slower your clock ticks compared to clocks far away. And this is not a metaphor. GPS satellites have to correct for it every single day, or your map would drift off by kilometers. Near a black hole, the effect becomes overwhelming. In NASA's simulation, an astronaut who only loops close to the horizon and then comes home from a 6-hour round trip, returns 36 minutes younger than her crewmates. She has genuinely traveled into their future. But you're not looping, you're falling. And as you approach the horizon, your friend sees something eerie. Your fall slows down and slows down. Your image grows dim and red because the light climbing out of the black hole's gravity loses energy on the way up to your friend. You never cross at all. You freeze at the edge, fading, as if the universe hit pause on you. Here's where it gets strange. Both stories are true at the same time. Your friend watches you slow and freeze at the horizon, fading from sight. You, meanwhile, sailed straight through and met your end in seconds. Relativity doesn't pick a winner. There is no master clock in the universe deciding what really happened. Each story is complete and correct from where it's told. And inside the horizon, it gets stranger still. The singularity, the crushing center, stops behaving like a place. Inside a black hole, space and time effectively swap roles. So the singularity isn't somewhere in front of you. It's in your future. You can no more avoid it than you can avoid next Tuesday. Firing your rockets doesn't help. Steering doesn't help. Every direction you can possibly travel points toward it, because it isn't a location anymore. It's a moment. A black hole doesn't pull you through space so much as it bends your future, until every path you could take leads to the same ending. So what actually happens to you at that ending? Your atoms, and the information that made you you. Honestly, we don't actually know yet. Our best theory of gravity, general relativity, says everything is crushed at the singularity, at densities where its own equations stop working. Our best theory of the very small quantum mechanics insists that information can never be truly destroyed. Both theories are spectacularly well tested. At the center of a black hole, they contradict each other. Stephen Hawking showed that black holes should slowly evaporate, leaking faint radiation over timescales vastly longer than the current age of the universe, and whether your information escapes in that radiation, scrambled beyond recognition, is one of the deepest open questions in all of physics. Solving it almost certainly means finding the theory that unites gravity with the quantum world, the biggest missing piece in science, which means this was never just a morbid thought experiment. The question of what happens to you inside a black hole is really the question of how reality works at its very foundations. Falling in would destroy you. Understanding the fall might complete physics. So here's the one thing to take with you. A black hole isn't a monster chasing you through space. It's a place where your future itself gets bent until every road leads inward, where your final 12 seconds and your friends forever are both, somehow, true. Got a question about the universe? Ask Hallie, drop it in the comments, and subscribe, because tomorrow we're chasing another one. And if this bent your brain in a good way, watch What If Earth Stopped Spinning next. It's the same trick. The physics you never notice, hiding in plain sight. Keep looking up.